Solve the inequality and then write the solution set in interval notation. We have 64x minus x cubed, which is greater than or equal to 0. So let's go ahead and solve. So the first thing we need to look at is if this inequality has 0 isolated on the right-hand side, which it does. Okay, so now what we want to do is, can we factor anything out of this particular inequality? Well, we can actually factor out an x. And then what's left is 64 minus x squared, which is now greater than or equal to 0. Okay, now if we factor a little further, this is the difference of squares. So that means we have x. Well, what do you have to square to get 64? Well, that's 8. What do you have to square to get x? Well, the answer is x. And therefore, we're going to have a plus and then a minus, and then that's greater than or equal to 0. Okay, so now what we've done is we've factored out our quadratic inequality. Now, to find the interval boundaries, we're going to set this quadratic inequality and write it as an equation so we can determine what our interval boundaries are. So we have x times 8 plus x times 8 minus x, which is equal to 0. And then we're going to use the 0 factor property. So we have x, which is equal to 0, or 8 plus x, which is equal to 0, or 8 minus x, which is equal to 0. So we already know that the first x is equal to 0. If we subtract 8 to both sides, x is going to equal negative 8. Over here, if we subtract 8 to both sides, we have negative x, which is equal to negative 8. Divide both sides by negative 1, and therefore x is equal to 8. Okay, so now what we've done is we now figured out what are our interval boundaries. So let's go ahead and then draw our number line so we have our interval boundaries. So we know we're going from negative infinity to positive infinity. And so we have 0 as an interval boundary. We have negative 8 as an interval boundary. And we have positive 8 as an interval boundary. So that means we have 1, 2, 3, 4 regions. The first region goes from negative infinity to negative 8 with a parenthesis. The second interval goes from negative 8 to 0. The third interval goes from 0 to positive 8. And then the last interval goes from 8 to positive infinity. Okay, so now what we're going to do is now we want to find testing points. So we're going to use testing points to test the interval. Okay, so let's go ahead and do that. All right, just going to move this over just a little bit. Okay, so let's take a look at interval number 1. Interval number 1, we can pick x to be negative 9. So x is going to equal negative 9, and then we're going to plug it in. So we have negative 9 times 8, well, x plus, so that's plus a negative 9, times 8 minus a negative 9. We want to see if that's greater than or equal to 0. So we end up with negative 9. 8 plus negative 9 is negative 1. This becomes plus, so 8 plus 9 is 17. Okay, so now we just need to say, okay, what is negative 1, negative 9 times negative 1 times 17? So negative 9 times negative 1 times positive 17 gives us 153. And so is 153 greater than or equal to 0? Well, the answer is yes. So therefore it's true for the first interval. Okay, let's take a look at the second interval. In the second interval, we can pick negative 1. So x is going to equal negative 1. And then we're going to plug it in. So we have negative 1 times 8 plus a negative 1 times 8 minus a negative 1. So we have negative 1 times, well, this becomes 8 plus a negative 1, which is 7. And then that becomes 8 plus 1, which is 9. So this is negative 1 times 7 times 9, which is negative 63. And is negative 63 greater than or equal to 0? Well, the answer is false. So therefore, it's false for region 2. Region number 3. We're going to pick the value of 1. So x is going to equal 1. So we have 1 times 8 plus 1 times 8 minus 1, and see if that's greater than or equal to 0. So we have 1 times 8 plus 1, which is 9, and 8 minus 1 is 7. So 1 times 9 times 7 is positive 63. And is positive 63 greater than or equal to 0? Well, the answer is true. So it's true for interval number 3. For interval number 4, we're going to pick 9. So x is going to equal positive 9. So we have 9 times 8 plus 9 times 8 minus 9. We want to see if that's greater than or equal to 0. So we have 9 times 17 times negative 1. Well, that gives us negative 153. And is that greater than or equal to 0? It's not, so therefore it is false. So it's false for region number 4. So where do we notice that it's true? It's true for region number 1, and it's true for region number 3. So now let's go ahead and then write our solution set. Well, again, here you see that it's greater than or equal to. Okay, so since it's greater than or equal to, we're going to have to use the brackets where our numbers are located at the intervals. So in this case here, we got negative infinity, comma, negative 8 with a bracket, union, we have bracket 0, comma, 8 with a bracket. And therefore, there is our solution. So let's go ahead and substitute this in here. So we have parenthesis, negative infinity, comma, negative 8 with a bracket, and then union, and then we have 0 and 8, both with brackets. So we have bracket 0, comma, 8 with the bracket. Let's check our answer, and there is our result.